Hello, welcome to the Hydrogen Education Foundation Student Design Submission by the University of Waterloo. Let me start off by asking, what is the state of our energy systems today? Currently, energy in Canada is supplied predominantly through oil, gas, and nuclear power. Power generation stations harness the energy from these resources, which is then distributed to end users through a centralized grid system. In this system, a surplus and instantaneous amount of energy is supplied to meet the ever-fluctuating demand at any given time. Urban communities are struggling with technical issues such as electrical grid congestion at peak demand and underutilization of excess power during off-peak hours. Now, what's the problem? In 2003, a blackout affected 10 million people in Ontario and 45 million across the US. The interconnectedness of the grid means that a grid malfunction affects everyone connected. Additionally, the current supply of energy is heavily dependent on petroleum, leading to an environmental epidemic. However, solutions to these problems are gaining a lot of attention. One particular solution is decentralizing the grid with microgrid systems and smart grid technologies. These systems would allow for the effective distribution of the energy amongst power generators and users by integrating renewable energy sources and storage devices. This results in a reduction of the need for oversized infrastructure, improving the stability of the electrical grid, and lowering the risk of blackouts due to overload. So what systems are currently being implemented by Canada? First, Bella Coola has a 2.1 megawatt hydropower station with diesel backup, operated completely isolated from the grid. Clearly, Canada is moving towards the use of renewable energy microgrids for remote locations. We propose to make a design in alignment to Canada's smart grid initiatives, but in Ontario. Since hydrogen has been proven to be a viable replacement for diesel generators, it will be used as an energy vector for this new system. The microgrid design supplies 10% of the peak energy demand as well as the full demand for 2 days during a blackout. Step 1 is to choose a location. After much consideration, the City of Cornwall was selected to have energy demands met for a fresh foods distribution center, 2 logistic buildings, and a residential neighborhood. Step 2 is the general design of the microgrid and data collection. An energy hub will integrate commercially available technologies in order to manage both the energy supply and demand in the Cornwall community. This allows the production of clean hydrogen on site from excess wind and solar energy, as well as the ability to interact with the electric grid bidirectionally. The hydrogen can be used directly as fuel for a fuel cell forklift, fleet, or vehicles, and also the generation of electricity via fuel cell for the bidirectional grid connection. The design of the system requires collection of fluctuating hourly data through the year of wind speed, temperature, solar irradiation, and community energy demands, as well as hydrogen demand. And further, the calculation of wind and PV efficiency. Step 3 is the design and optimization of the system. An economic objective function was used to calculate the most cost-effective design. Post-processing analysis shows the design is environmentally friendly. What makes this design unique is the implementation of vehicle-to-grid technology. Fuel cell vehicles use hydrogen fuel to produce electricity for running the vehicle, but also as a potential source of electricity in a time of grid failure. Step 4 is to take the optimized number of components and configure them into a potential microgrid design. Welcome to the Cornwall Microgrid Roadmap.